Hi, my name is Robin. I'm an aerospace engineer working with Elsas Tech, and today we're going to do a demo of space events using STK. Now we're going to show you how to use the external propagator and an external ephemeris source to propagate a new satellite. So we're going to go in the Insert button, click New, select Satellite, and select From External Ephemeris method, and click on Insert button. Now you just have to navigate to your file location and double-click on it to load it into STK as a satellite. So first we're going to assess the longitude box of our satellite, and we're going to right-click on our satellite object and click on Report and Graph Manager. In this Report and Graph Manager, we will create a new graph called longitude. And we're going to select the LLA state data provider, fixed, and the longitude element, and insert it into our y-axis, and click OK. And now that our longitude graph is configured, we can just generate it. As you can see here, our satellite of interest is shifting from a longitude of 4.6 degrees to a longitude of minus 0.58 degrees, which is a westward drift. And in order to do this shift, it has to maneuver. So we see that it was keeping very defined longitude box here. And we can zoom on this region from the 8th of June to the 24th of June, approximately. We can see that it was staying well between 0.01 degree bounds, minus plus 0.01 degrees, and then it suddenly shifted towards a new longitude box, which is this one. Here we can see that the bounds are similar in terms of order of magnitude, 0.01, 0.03 degrees, but the central longitude has changed to minus 0.55 degrees. So we're going to make it look better in our 3D graphics window and visualize this latitude-longitude box. In order to do that, we're going to open the satellite's properties and go to the 3D graphics page, proximity page, and show the geostationary box in order to configure it. So the longitude field is your central longitude, and we're going to select minus 0.55 degrees, and the north-south and east-west are your latitude, respectively your latitude and longitude bounds. So in this case, 0.03 degrees for each of them. And the radius is your satellite's altitude. So now we see that at our starting point, our satellite is still not at the final geostationary box, but over time it will slowly shift to this geostationary box. But in order to understand better this movement, we're going to change our orbit system. So in order to do that, we'll go to the satellite's property, 3D graphics orbit system page, and disable the inertial by window orbit system and switch to fixed by window, and click OK. One last fix we have to do is to change our reference frame for our 3D window. So we're going to click on the View From To small arrow button and click on the View From To button. Here we're just going to switch reference from Earth inertial axis to Earth fixed axis, and click OK. Once we zoom back to our satellite and we play the animation button and increase the time step, we'll be able to see the satellite slowly drifting to its new longitude box. And here it comes right in position and in station keeping in this particular latitude-longitude box. So now we're going to use another tool called the Advanced CAD tool in order to understand why this satellite has maneuvered to another latitude-longitude box. This tool is going to allow us to compare the position of this satellite to the position of other satellites in the satellite database from STK. In order to do that, we'll insert a new AddCAD tool object and select the Define Properties method. To correctly configure the AddCAD tool, we're going to first select a primary, which will be our satellite of interest, and we're going to make sure that the class of its thread ellipsoid is selected to covariance, since we are using an external ephemeris, which includes covariance data. In the secondary list, we're going to select the stk all.tle.tc file in order to compare our primary to all of the satellites included in the database of STK. Once we've done that, we're going to make sure that we use a range measure and select the threshold to be of 50 kilometers, and also select the display acknowledgement when down box. You'll be able to see this pop-up message to confirm that your AddCAD tool has successfully computed your analysis. Now we are able to generate new reports that will indicate whether or not our satellite was in close proximity to any other satellite. So we will go to our object browser and right-click on the AddCAD tool we just created, click on the Report and Graph Manager, and generate a close approach by range, by minimum range. We'll just double-click on it, and we'll be able to see which object was the closest to our satellite. Here we do not have the name of our objects, we just have the NORAD number. The 55841 object is actually our satellite of interest that we used. It's just the TLE, so this is normal that we have a close encounter with it because our ephemeris is different from the propagated TLE. So we're just going to select the second one, which is the closest other satellite. So our NORAD ID here of interest is 40613 with a minimum separation of 12 kilometers. Now we just have to insert the satellite and start analyzing it. We're just going to copy the object's NORAD ID. We're going to go back to the 3D window and click Insert, New Satellite. And we're going to, this time, insert it from the standard object database. We just have to do a short Ctrl-V and click Search. We'll use the data source from AGI Standard Object Data Service. It's an online data source, and we'll click on Insert. We already have a little bit more information on our object, secondary object. It's 47, Norwegian satellite. So we saw that Luch started with a longitude-latitude box located around 4.6 degrees of longitude, and that suddenly it changed its trajectory to reach a new longitude-latitude box. So here we can see Luch maneuvering towards its new destination, and we try to understand why it suddenly changed its position. And in order to understand better, we run the AddCAD tool to see if any other satellites were in close proximity to Luch. And that was strangely the case. And here we can see our two satellites operating in respective longitude and latitude box. Here we are witnessing Luch finally arriving to its latitude-longitude box that we determined earlier, and in very close proximity to the Norwegian satellite 4. We've been able to assess that these two satellites were in extremely close proximity, and the minimum range between these was 12 kilometers. Thanks for watching, and come back for more demos of STK with ELSA's Tech.